Good morning. No, this is not stuttering. This is just me. First though, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. And right now, you know that thing where you've got the stuttering effect because your bandwidth just isn't up to the job? That's my brain today. I'm medicated and I'm doing my best. We'll see how things go. So, there are a whole lot of people here right at the start of the chat. Normally it takes a little while for viewers to arrive, but we've got a bunch of people. And I've lost my mouse cursor. Hang on, I've got to spin the trackball a little bit. There it is. Found it. Okay, so in the chat, we've got many people here. G'day to Mako, Amuri, Henrik, Daryl's there, Frank, and Peter Lawler down in Tasmania. I should ask, Peter, have you received the little surprise package that I sent you? Well, it's not a surprise to you. I'm just not saying on the live stream what it is right now. So if you did, I would like to know that you're that it got to you okay. So, oh, hang on. Everything's going wrong here. I've got this window snap thing running on Mac OS, which lets me drag windows to different places and they resize so I can do like left and right half windows to have two things visible at the same time and go into quarters and all of that sort of thing. And sometimes I drag things into the wrong place and it all goes very badly wrong. Peter, you haven't received it. Okay. Yeah, a week Australia post from Melbourne to down the island down south is, yeah, right now that would be a bit ambitious. Hopefully you'll get it soon. All right. Yeah, actually, we had a situation where I posted something to Andy. So Andy lives approximately 24 kilometers from me here in Melbourne. And I posted something to him and it took nearly 2 weeks to arrive. It got there only a few days ago after I posted it a couple of weeks ago. So that is the state of the world right now. All right, enough randomizing. Let's see what we can talk about today. Now, one thing I had in mind, just as a starting point to kick off whatever may come, is to have a look in Discord, because it has now been a month since I've even looked in the Superhouse Discord. So I'm sure there are just 1 or 2 notifications that I've overlooked, probably a few questions, and I've just opened Discord and I can see that there are a whole lot of DMs. So my apologies to everybody who thinks I've been ignoring them. So what I could do is start off by having a look through Discord and see if there are things in the questions section, live stream questions. Yes, nothing much in there at the moment. And streams. Oh look, I can see Andy is in there. All right. That's all right, Andy. Andy's going to concentrate on the swag badge firmware today. So a little bit of update on that, because there are a few people on the stream who I'm sure are interested. The conference badge, now this is not actually the final one. This is, or is it? No, this is the final hardware, but this is my test version of the badge. As many of you would know, a group of people who normally put together the Open Hardware Miniconf each year have been working on putting together a conference badge for LCA 2021, which will be online in January. And this is my little test rig for it. And what else can I find here? I've got stuff piled up on my bench. This is the version 1 PCB, which had a minor flaw, so we had to fix it to do the version 2 PCB. It was just a pin allocation error. So as you can see from this one, the screens and things are mounted close to the PCB, and on this one, this is my test rig, so I've got sockets on here. I can use this for testing OLEDs before I put them on, and Lowlands, which is also socketed. And this Lowland I've hacked to put a reset button on the back of it. I scratched away some silkscreen. There is a spot just here where the reset line is exposed, and the whole back plane is ground plane. So all I did was use a scalpel and scratch away a little bit of the solder mask in the appropriate place, and I just soldered a button on. So that is now a reset button on the back of the Lowland, and you'll see the two screens refresh just up there. There it goes there. And that was the Lowland rebooting. So these are conference badges for LCA 2021. And I had a horrible thought that I was going to drag a microphone cable out of the computer then. So hopefully I can do this without dropping everything. This is one of my little laser cut PCB trays with 20 of the conference badges in it. Which way does it go? That way. So these are conference badges that have been prepared, and they just need the final firmware loaded on them, and then they can be sent off. And there are a couple of trays of those up here, and there has been an epic effort over the last couple of weeks by John Spencer and Andrew Nielsen, who have been soldering more of those together. So they're almost at the point where they're going to be shipped out. Oh, and we've got stickers to go with them, and we've got simple add-ons and all sorts of fun things. All right. Snoot button, yes. Now that one was just a reset button, not a snoot button. There, somewhere around here, I think I've been cleaning up a little bit recently, and I put my smart switch stuff away in a box. So the board with the snoot button on it is currently packed away, but I can get it out. All right. Peter. Yes, you could have come over to help. Jump on the ferry. Stupid virus. Yes. So, where was I? I don't know. I started talking about swag badges. Okay, yes, there was actually a point that I was going to get to there, which is in relation to failure rates of stuff that we've bought in order to make these badges. To show you something, I'm going to have to use my portable camera, but let's switch to, where are we? Portable camera, which is currently pointing out the window because it is such a cool looking day today. I like days like this. It's just a little bit damp, it's a comfortable temperature, it's not hot. And this is the view out of the window of my lab. I opened the blind this morning to get a little bit of natural light in, and you can see looking past the pick and place machine there, looking out into the backyard. And if I move, where are we? Just there. And then I'll see if I can point past the camera. There we go. See that little thing down there? That's the auto mower sitting on its dock, waiting to go off and mow the lawn. And you can see there's a conservatory down in the, not a conservatory, that's a gazebo down in the back corner, which is actually where sitting in that gazebo with a laptop was where I wrote most of, what was it? Ubuntu hacks. Many years ago in the back veranda. Yeah, that gazebo down there actually has conduit running out to it, and it's hardwired, so there is power in there. There are GPOs in under the floor, under a hatch, and it's got Ethernet wired out to it as well, but there's also Wi-Fi coverage. So I sat out there with my laptop, and also a fair bit of the text of Practical Arduino I wrote while sitting out there as well. Now, what are we up to? Back here, okay. What I was going to show you, it's all got shoved in as a big nasty mess on my bench, but this is what I've just been going through. Get these out of the way. Look at this, all of these are failed OLEDs. And oh, there's a D1 mini shield. I'll talk about that later. So all of these are OLEDs that have failed when I connect them for whatever reason. In fact, just for the fun of it, I'm going to try. Let's see, is this one left or right? That one is left unpatched. So I'm going to pull that out. That's a working one. Plug this in, restart, and see what happens. Yeah, see, this OLED is dead. Nothing comes up on it, even after I reset the Lowland. And what happened was that I started putting the first couple of badges together. So what should happen is this. I'll put the working one back in, hit reset, and after a couple of seconds you can see they're both showing something. It's flickering on the camera there, but to me that just looks like it's constant. So I've got all of these failed OLEDs. They're little I2C OLEDs, you know, the really common 0.96 inch, I think they are. I'll put that camera back there and then switch back to the other view. Back to here. Alright, so these OLEDs, they cost, I can't remember the number, but it's in the order of like $3 each. They are amazingly cheap for what they are, and they're super handy to put on projects. Because they're I2C, they often don't add any extra pins to your I/O. All you need to do is add power to them. And if you're using any existing I2C devices, then those pins are already allocated. So it means you can add a little display to your project and do things like report the IP address that it's been assigned, or, you know, provide some kind of a status display. So these little OLEDs are awesome. I love them. In different formats. This is the 128 by 64 format. I also really commonly use the 128 by 32, which are the long skinny ones, because they're even cheaper. And that's enough information. It's enough of a display to be able to just show some status information or an IP address, which initially is what you want. When you have a device come up on the network, you need to be able to connect to it. Just have it display its IP. Very cool. Okay, so back to failure rates. I ordered 660 of these little displays, which is one of the larger orders I've ever put in. This was on AliExpress. And the first couple of badges that I started assembling, I had a couple of these fail. And I thought, that's a bit odd. That's more than I expected, because in the past I've generally had good experiences with these. I just get them, solder them into a project, and they work. Very rarely you'll have one that fails. Or sometimes they're damaged in shipping, of course, but in this case, each one of them was inside a little clamshell box. In fact, here is one right here. So they came packed in these little, which side is it? That side. These little plastic clamshell boxes, which are awesome because it means the display is nicely protected. So each display was in these, and then these are snapped closed, and these were all in big bags. I think they were bagged up in 100 per bag, so they were big bags like this. Because we're doing several hundred of these conference badges, and we need 2 displays per badge, and I was allowing for building extra units for testing and also for the development team. They need multiple badges each so that we can do things like work on the firmware and test interaction between badges. So that was why I ended up ordering 660 of the displays. And in the end, because they were beginning to fail, that's actually why I built this little test rig. And the test rig is nothing but a regular badge but with headers on it instead of the OLEDs being soldered directly in. That way what I could do is plug every OLED in and test it before it gets soldered into a badge. And I discovered that I was getting a failure rate of just over, no, it was just under 10%, which is really, really high. And there was no obvious reason for it. I mean, I could chuck this under the microscope right now and show you, but yeah, why not? Let's chuck this under here. Give you a better view of what one of these things looks like. Come on, microscope. Go, go, gadget microscope. Change. Come on, OBS. Change. I want microscope. There we go. All right, I'll get that. Oh, I always forget that this has my other screen visible there as well. So let's see. Need to zoom out a bit. Oop. So that we can see what's going on and get some focus. It's also a bit too bright on the camera, so I'll turn the illumination down. All right, so this is the back of the screen. I just grabbed this one randomly out of the pile, and I've just visually inspected a few of these, and I can't really see any particular problems. Now this is going to be harder to tell. So we've got there's the glass screen on the front, and that has the little tail, the flex cable that wraps around, and it's soldered onto the PCB on this side. And then you can see, in terms of assembly, this one looks fine. All the parts are on it, all the joints look okay, and the connections to the ribbon cable are probably okay. I could look at this in a bit more detail. I don't think there's a lot of point, but a visual inspection doesn't really reveal anything out of the ordinary, but that display just doesn't work. And I think the problem is in the controller chip, perhaps, or maybe there is a flaw in the flex cable because it's been wrapped around. There are a few different things that could have gone wrong. Interestingly, as I've been inspecting these, I've seen, what can I find a point with? Okay, just down here somewhere there is, or is it that one? I think it might be this one. I've seen one or two of these where one of these capacitors was missing. It just wasn't even installed on the board, and yet the display works perfectly. So it's probably just like a decoupling cap or something. But that sort of thing just shows that there is probably no or very little inspection or testing that's happening on these modules. So what happened after all of that was I contacted the seller. So we had 660 of these, and I think it was about 64 that failed out of the 660, which is a pretty scary number. It ends up being quite significant. So instead of having some headroom, like some margin in terms of units we needed, we ended up not having enough. And I contacted the seller, and for an AliExpress seller, he was actually incredibly responsive. Jumped on Skype with me, chatted through what I'd seen and wanted to know more about it and what I was doing to test them. And I then ordered, because I was starting to run out of time, what I ended up doing was just placing another order for, I think it was another 80 units. And he confirmed, like while we were talking via Skype, he confirmed that he'd got the order, that they had all the modules and that he was going to ship them. So he then DHL'd me another 80 units. DHL? Yes, I think it was DHL. And I got them only a few days later. So in terms of getting replacement units, it was pretty quick and painless. And then I tested them. This is the interesting thing. From the same seller, I received this little box of an extra 80 units. I tested them all, and every single one of them worked perfectly. And that made me wonder a couple of things. But firstly, because I had been complaining about the problem of these units failing, perhaps they had gone through and tested and only sent me ones that they had verified were working. So in the follow-up, the box that I got, 100% success rate. And based on the failure rate of what they had sent me in the previous batch, I was expecting to get maybe, between 7 and 10 failures, give or take. Given that I'd ordered 80 of them and I was getting approximately a 10% failure rate. So interesting. I don't know quite what to make of that, except for the fact that they probably went to the trouble of testing all the units that they sent me as replacements. So, anyway, I have been totally ignoring the chat, even now. Oh look, there's the chat. So, what do we have? Oh, yes, okay. Andy, I'm trying not to say anything too much to distract Andy. Right now, he is working on the firmware for these badges because we've got this deadline to get these shipped out. And we need minimum viable firmware on them, and we need to flash hundreds of them, which is going to take a couple of minutes per badge, and they all have to be tested. And when you multiply the numbers out, it ends up being many, many days of work just sitting there plugging in USB cables, running the scripts to flash them. Next one, USB cable, flash. When you're doing things at scale, time just blows out in a crazy way. Marie just said, Andy, go back to work on that firmware. So yes, that's right. Andy has just pinged me through like he's just private messaged me. And he said, worth mentioning that some OLEDs for sale swap 3.3 volt DC and ground, which caught us out. Yes, that is actually why we have... What happened to my... I don't know what was going on then. OBS just changed screens and I hadn't clicked anything for a minute or two. So that's actually the reason for these two versions. On this board, this one, yes, this is the original one. It's actually hard to tell them apart. On this board, ground and VCC had been swapped. And so that is because these modules, there's no real standard for them. There are conventions but not standards. And if you go to different manufacturers, they will be off. Like if you look up data sheets for these, even things like the dimensions, they can vary by a millimeter or two in different directions. And it's because everybody's copying from each other, but they've all got their own little variation on it. And so what they might do is lay out the PCB again from scratch, but it'll be a copy of the basic layout of someone else's PCB, but then they've sat down and relayed it out so they can generate their own Gerbers. And so what you'll find is that things like spacing on the mounting holes might not be quite the same. Some of these are on imperial grid, some are on metric grid, and they'll be an approximate equivalent, but they're out by a fraction of a millimeter. So there are variations. And one of the variations that can really catch you out is differences in the pin order. Because you can order displays from different manufacturers that look in the photos on AliExpress to be exactly the same, and they'll have different order on the pins, which really sucks. So what happened was that on the first version of the badge, we were looking at a data sheet or some pinout diagram for from displays from one manufacturer, and then that was how the badge was done. And then the displays we got, which are these ones, had the VCC and ground pins swapped compared to the footprint that we used the first time, which meant that our PCBs and our displays did not match. And the fastest and cheapest way to solve that problem was just to order new PCBs with the pins swapped. Because the value of the PCBs, it's only, in round terms, there may be $1 each, approximately. But this has a couple of displays on it, and the displays are, say, $3 each, and there are 2 of them. So you either replace $6 worth of displays, or you replace $1 worth of PCBs. And we ended up just ordering new PCBs with the alternate pinout. So I now have big packets of these version 1 PCBs that will probably never be used. And it's not... In fact, we looked at the possibility of ordering the other displays with the other pinouts just so that we could use up the other PCBs. And the difference in price with that pinout was more than the difference in the value of the PCB. So anyway, that's just the way it goes. All right, so the Lowland 32s, because I also ordered, how many did I order? 320 Lowlands, which are it's this ESP32 based board that goes on the front of it. And the failure rates on those were much, much lower. Like only out of 320, only a couple of failures. Well, a couple of weird ones. There was one that had an odd value crystal on it. And this totally baffles me. It was meant to have, I'm trying to remember the numbers. I think it was meant to have a 40 megahertz crystal, and it had one that was like 41.01 megahertz, or I don't know, something weird. It worked apart from that. It's just, it would probably have problems with timing. I don't know. And we had a couple that failed. We had a couple that had looked like they'd been reworked. And there was one that, in fact, I've got photos of these somewhere, but I won't try to find them and waste your time while I'm doing it. So there was one, let me see, in fact, I'll just pull this off, stick it under the microscope and show you. So this is one that's working. Give me a microscope, yes. And you can see there, oh, it's upside down, that way. So this chip right here is the ESP32, and you can see its little memory chip next to it. And it's very hard getting the lighting right with this under the microscope. So yeah, pin 1 is up here. And this one, you can see the chip is quite clean. There's no sign of residual flux around here. Everything looks fine. And you know, there are no solder bridges. So this is a good one. It came out the right way the first time. And what I found just visually inspecting them was that I caught a couple of them where there was a lot of flux residue all around here, all around the processor. But there was no flux residue on the rest of the board. And what that suggests to me is that the board was assembled and then it went through an ultrasonic cleaner. So the whole board was left clean, but then the board failed and they then tried to rework the processor. So they've manually added some flux paste or some gel or whatever around here and then reheated and either used hot air or whatever to rework it to try to get the board working again. And then they didn't ultrasonically clean it afterwards. So it was just left with the residue of the flux around here. So that was only on a couple of boards that I saw. But interestingly, there was one that we received that was like that and that didn't work. It was actually one that failed testing. So what happened was I tested it, and then because it failed, I was curious. I chucked it under the microscope and I found that it had all of the flux residue all over it. So what that means is that at the factory, they had tested it, discovered that the board was not working, sent it back for rework, and then they've reworked it to try to reseat the ESP32 or clean up the connections or remove solder bridges, whatever they needed to do. And then it still wasn't working, but they shipped it anyway. Which is, what? If you've gone to the trouble of testing it and discovered that it needs reworking, why would you rework it and then ship it when it still doesn't work? I don't get it. So maybe it was just like a process mistake. Someone reworked it and then they put it into the wrong container as they finished. They put it into the fixed container instead of the unfixable container or something. Who knows? So yeah, that was interesting. And also there was one that failed. It would actually be nice if I could find the photos of this. Let's see what I can find. I may have, hang on, I'm going to get rid of, so I'm on the microscope view, I'm going to get rid of middle monitor just for now, while you've got a view of that thing under the microscope, which is actually very hard to see. Yeah, trying to leave you with something that looks pretty, but that'll do. Okay, let's see if I can find these photos, because I took photos through the microscope when I was working on these boards, and it is kind of interesting to see how things come from the factory, what you receive. A lot of the time when you just look at a board with the naked eye, you look at it and think, oh yeah, that's fine. Oh, hey, look, OBS just changed screens. What is going on? I think it's because of the touch portal thing that I've got. It's got an extremely long delay on it. And it's finally catching up to when I tapped on it a couple of minutes ago. So let's switch back to there. Okay, what was I doing? That's right. I'm going to go for a quick look through my file system, and I should be able to find it without too much trouble. No, not that. I want it in, it's in projects, swag badge. Yeah, there have been a few times where I've received boards and are the pictures there? No, they're not. And when you first look at them, it just, the boards look fine, but then you put them under a microscope and you realize that, nah, the images aren't there. Actually, I know where I can get the images from. They are on they're actually public, they're on the blog. Here we go. I will grab them off here. They're on the wiki. All right, so I want that one, and let's just drag this over here. This is the simpler way to do it. Let's get back to the desktop, and this is the openhardwareconf.org wiki, which is where we do all of the Open Hardware Mini-Conf stuff each year. So this is a blog post that Nicola wrote explaining what was going on with this. Now, this image, and I'll get them open side by side so you can see them both. Yeah, so you can see two ESP32s there. The one, and these are from two different PCBs, two different Lowlands, arrived in the same batch, and neither of these have been touched. This is exactly how they came in the original packaging, and we open the anti-static bag and this is what we get. Now most of them look like this one on the left, and this is what you expect to see. It's nice and clean, there's no flux residue, it's obviously been through a cleaner or something, either an ultrasonic cleaner or someone wearing some gloves and dipping it into a bath of really nasty stuff that would cause OH&S problems if you try to do that in Australia. And yeah, I don't know. There is something that I've used. I've been to quite a few different factories in China with varying levels of professionalism. And there was one really little factory that I went to, when would it be? It must be 10 years ago. And yeah, their cleaning process was they had a plastic container, and there was a guy wearing rubber gloves, and he had like a little brush, like a toothbrush sort of thing. And basically the boards would be coming in on his left, and he'd pick up a board and dip it into this container of stuff. I don't know what it was, some kind of nasty chemical, give it a bit of a scrub, and then put it on a rack on the other side, and it would move along. So that entire factory, I'm trying to think about how, it was a very manual sort of factory. They were doing lots of hand assembly, like short run prototypes and things. It wasn't really set up for mass production and large volume. And it was in a little back alley. That particular one was in Beijing. So when we think about manufacturing in China, most of the time we're thinking about Shenzhen, which is way down in the south, just over the border from Hong Kong. But a lot of the early electronics manufacturing in China was oriented around Beijing, right up in the north. And that was before the real the special economic zones like around Shenzhen, took off. There was like this, there were companies based around Beijing that were as competitive as anywhere else. And it was because of the special economic zones and all of the things that happened around Shenzhen that area really just started dominating. Anyway, that was a random squirrel to chase. So this particular factory was it was in Beijing, or on the outskirts of Beijing. It was a bit of a drive to get there. And so this factory, at a guess, it would have, in fact, I've got a photo of myself at this same factory, and I thought it was kind of funny. I don't know if I'd be able to find it. Maybe I will. Anyway, I've got a photo of myself with a couple of the people at the factory, so the factory manager and my production manager, a couple of people, and we're all wearing yellow anti-static vests, like cloaks. And at the time I was probably similar size to I am now. I've put on a bit of weight recently, so right now I'm back up to about 92 kilos. So for reference, I'm 6'2", 92 kilos, like 187 centimeters, and they did not have any clothes that were big enough for me. So there's this photo where I look absolutely ridiculous. I'm wearing this yellow anti-static cloak, which is jam tight, stretched over me. It's got one button done up at the front, and it looks like it's about to explode. And the sleeves come up to about here. It looks silly. Anyway. And in this, I have no idea how I ended up on this subject. So so this little factory, they were cleaning, my brain is all over the place right now. So they were cleaning PCBs by having this guy sitting there with rubber gloves, dipping them into this bath of stuff that would probably kill you if you breathed it, and scrubbing it off with a brush. So that is not typically the way it's done in a better run factory. And so this board on the left, getting back to the subject, has obviously been cleaned. There is no flux residue on this from the reflow process. And you can see that the joints are nice and consistent, so there are no bridges around here. That's what you hope and expect to see. However, what you see on the right here is a board that we received in this same package. And if you look down the bottom here, actually I wonder if I can, that one is scaled down. Let's go to the original so we can see it a bit better. We'll drag it up here. So this is a photo I took through the microscope, and you can see down the bottom there is a solder bridge between these two pads. There is another solder bridge between these two pads, and you can also see that there is just crap all over the place. There's this residue from the flux when they were reworking this. So you can see that someone has received this board and squirted flux over the ESP32 and then reheated it to try to reflow it. And perhaps they improved things, perhaps they didn't. But in any case, they left it with the solder bridges and it didn't work out of the box. Plugged it in, the board didn't work. I haven't actually even looked up what these pins are. But the end result was that this board did not boot. So all I did was remove the solder bridges and I cleaned it up, and the board ended up working just fine after that. But the interesting thing, Mako said probably killed the chip. No, it worked. So this board came up just fine. It was just those solder bridges in this case. Now the thing is, I don't know what state this was in before. Before it was reworked. It may have looked better than this, it may have looked worse. I've got no idea. But after they reworked it, this is what it looked like. And then, and you can also see there's inconsistency down the side here. So they've done something. If you look down on this right-hand side, you can see there are variations in the amount of solder that are on these pads. There's like a solder glob sticking out on these pads, like there's just a little bit too much. Looks like maybe there's not quite enough on these pads. It's a bit all over the place. Across the top looks fine. Those connections look good, they're all consistent. Some down the left looks fine. Like, look at all of these pads. That's nice, that's what you expect. But it's got these solder bridges. So, all I did was rework the chip and everything was good. Yeah, Peter said, how are even though those right pins connected? Looks like a complete mess. Yes, sometimes it's a little bit hard to tell. This is one of the reasons that I do not like QFN chips. So QFN stands for Quad Flat Pack No Lead, and No Lead and BGAs and things like that, they drive me nuts because you can't really tell what's going on. With this view looking straight down on the top of the chip, you can't really tell if the solder is bonded to the pad or whether it's like it hasn't wetted properly. So what you can have happen is if there is a little bit of corrosion on the pad of the chip, the solder can ball up on the pad of the PCB and then not bridge. So you've got the edge of the chip, I can't make my hand go into the right shape, edge of the chip, and then it's sitting on the PCB, and so this surface edge of the chip is where you want the solder joint to go, and what you can end up with is the solder balled up here on the PCB and not bridging across to the chip and making a good connection. And so normally what I do when I'm doing QFNs is to inspect them. I look at the PCB from different angles. So you have to put the board under the microscope with enough vertical clearance that you can move it, and then tilt the whole thing so that you're looking down into the joint at a 45-degree angle. So if you're looking into this part, for example, you're looking at an angle. In fact, why don't we just do that? Let's see. Let's see what we can see. Microscope. Give me the microscope. All right, so typically what I would do, normally I'll drag the microscope off the edge of the table. So right now it's off the edge of the bench. You can probably see in the little camera view on the side there. If the microscope is over the bench, I can adjust the height, of course, but the quickest thing is usually just pull it off the edge of the bench, and that gives all of this space to work with. Grab the target board, whatever it is that I'm wanting to test or inspect, and then just brace my fingers on the edge of the board and have a look. So what you can do, well, let's get some zoom happening. And the focus is the distance between the lens and the device, which means that then to focus, I just move it up and down. I don't even bother touching the microscope. So I just tilt it at a 45-degree angle, move it up and down until I get about the right thing. Now I've got to turn up the brightness because we're further away, and also black PCBs do not help. I've got to try to get some focus. Now if I angle it, you can see there, it's a little bit hard to see through the camera. As I've said before, the view is much better through the stereo eyepieces than it is through the camera. But you can see there that each of those joints looks like it's nicely wetted and connected to the chip. And then, so what I do basically is I just rotate. I'll go like there, 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 and rotate through each of the four sides and do a quick inspection and make sure that it looks like all of those joints are okay. But if you're just looking straight down at the chip, I'll try to get some focus happening. If you're looking straight down at it like that, you can have joints that aren't connected properly and you can't tell. Or it's not so obvious, at least if you're looking at it directly on. So, back to desktop. Yeah, when you chuck it under the microscope and it looks like that, that's a bit of a warning sign. All right. Let's see. What would be actually interesting to show you is the dodgy little fix that I did since I'm playing around with the microscope today. Let's see if I can find one. I don't know that I've got one that's been patched and doesn't yet have an OLED on it. No, it doesn't. Oh, I can show you something. Let's see. All right, I'm going to go digging for PCBs and chuck some stuff under the microscope to show you what I'm looking for are the dodgy PCBs. And I think this is one of the dodgy ones. Now, hang on, I've just got to hit mute for a moment because I've got, hang on, mute. Is mute going to work? Maybe. What was I looking for? Yes, hang on. I need to grab something to blow my nose, which is not something that you want to hear. Just a second. Okay, so I'm back, but we need the microscope view, don't we? So let's have a look as a comparison. Brightness down because we've got a nice bright white PCB here. And I'm going to try to, we'll do a comparison between the correct PCB, as in the one with the right pin out, and the one that is not the right pin out. If I can find another PCB. Looks like I have to open a packet. I have spare packets of PCBs here. How many is in that? 25, I think. So there's another big pack of the badge PCBs. But these are the ones with the corrected footprint. And it's warming up in here, so I've just hit the cooler. Now, let's see if I can get some view that is going to show what's going on here. Now, that and, oh yeah, we might be able to see this. Let's see if we can reduce the brightness enough that you can tell what's going on. All right, so what we've got, it's hard to see through the white silk screen, but look at this. So this is the first version of the PCB, and you can see here that there are connections between this second pad and the top polygon pore, which in this case is the top ground or 3.3 volts. I don't remember. But this particular PCB, one side is 3.3 volts and the other side is ground, which means that if there is a pad that needs to connect to one of those, it just links through to the appropriate polygon. So what we can see here is that this particular pad is connected to the top polygon pore, and this pad is not. You can see that there is no connection around it. Now this is the badge with the reversed power connections. So remember that. Top polygon links to the second pad. Now I'll slide across this one. This is the updated PCB. And you can see that the second second header here is not connected to the top polygon, and the end one is connected to the top. And if we looked on the other side of the PCB, we would see, in fact, we can look at it here. Oh, it's even labeled. Isn't that nice? So we can see that the end one is ground, and then So it's 3.3 volts on the back of the badge, ground on the front of the badge. And you can see here that it's connected through to the background port on the second pin. So that is the major difference. There are some other little silkscreen differences, but that is basically the difference between this badge, which is the new one with the correct pin out, and this badge, which is the old one with the incorrect pin out. Now, in order to make this work, what I did was I ended up reworking some of these badges, and I did it. So this one we're looking at right now, this is the badge that is incorrect. And what I ended up doing was using a scalpel and cutting these tracks here, like these little connections that go through to the polygon. I'll see if I can get this out. So make a cut there. I'm not going to go through all of this because it'll take a while. But what I did was cut this, and that isolates that pad from that polygon. And it means that it's no longer tied to, which was this? This is the front of the badge, which means this one must be the ground connection. Or the top is the ground polygon. So what I did was remove that to isolate it from its ground connection. And then you flip the board over and you do the same thing on the other side. Cut these tracks here, here, and here. And you then end up with those two pins floating. They're no longer connected to the incorrect power plane. And then what I did was, you see this one here, which is ground, but it's connected to the far side, and it should be connected to the close side. Then I just scraped off some of the silkscreen here, which exposes the local polygon, the one on this side, and then I used some wire wrap wire and I bridged across between them. And the tricky thing was I needed to be able to bridge this one to the far side, but the far side is where the OLED goes in, and it needs to, this thing needs to be able to go into it and sit down flush. So what I did was, on this side, I scraped off a little bit of the silkscreen here, and then I got a tiny bit of wire. I'm ending up kind of going through the whole thing here. So I got a little bit of this wire wrap wire, which is very handy stuff. It's probably actually worth mentioning this because for people that haven't done board rework, they may not know about these sorts of tricks. So what I did was made myself up a little patch wire like this. Now you can see that there is this little strand of wire, and what I should do is show you what I'm talking about, although it's attached. How can I show you something? I don't know, I'll just cut off a length. Alright, so coming back to the front camera. So this is a little piece I just cut off with that wire wrap wire. Wire wrap wire is single-stranded, very thin wire with a layer of insulation on it. And I'm not going to go into wire wrapping right now because it's pretty much an obsolete technique. I built quite a few boards using wire wrapping way back in the 90s, but I haven't done any wire wrapping for a long time. I just use wire wrap wire, which is a really common thing to do for board reworks because it means that you can have very, very thin connections that you can attach to different parts of the PCB. So then you can just strip off the insulation and use this as super fine jumper wire. Because regular jumper wire is typically multi-core, and when you solder it, the multiple cores can spread apart. Often you just want a single strand, and that's what this is ideal for. So what I did then was, with this little piece of the wire wrap wire, I will see if I can get it into a spot where you can see it on the microscope. Alright, so I put it through like this, and fed it down through the hole and then soldered it on to that little point right there so that it was attached to the polygon on this side of the PCB, but it was then going down through the hole. And what that allowed me to do, now it's probably going to fall out if I pick it up here, but what it allowed me to do was then insert the OLED, and it goes in through the hole. Now I'll see if I can get an angle on this where we can see what's going on. Come on, give me some focus and some light. Alright, now if you look at it there, you can see that wire wrap wire is poking out. Oop, wrong way. I want some illumination. There we go. So you can see the wire wrap wire is poking out just here, and what it would have been, so on the boards that I reworked, that would have been soldered on right there. So it's attached electrically to the polygon on the top, and it goes in underneath a little bit of plastic, and it goes through. Now I'll try to hold all of this together, and you can see that it comes through the hole beside the pin, and then I'd cut it off. So you can see here, where are we? There. So you can see the wire wrap wire is going through the hole next to the pin from the LCD. And then of course when you solder it in place, so you solder the LCD in place, OLED, the OLED display. In fact, OLED, we call these things OLEDs, but it is not an OLED. An OLED is a single LED, an organic light emitting diode. This is a display based on OLEDs, so I really should call it an OLED display. So anyway, so when you solder this on, so you get the soldering iron in here where I've got the tweezers, and you solder this joint, the end result is that you end up with an electrical connection between the pin of the display and the other side polygon of the PCB. So, was this one that I cut? No, maybe I'm showing you on the other side. Where did I do that trimming? Don't know. No, I think I just didn't trim this one. So this, remember that this would have had the connections cut between the pad and the polygon on this side. At the moment, if I did this, this would be a short circuit between ground and 3.3 volts, because these little connections right here are still in place. But if I had used a scalpel and cut those off, this pad would now be connected to 3.3 volts on the other side of the board and not to ground. Or something like that, whichever way around it goes. So I ended up with those little jumper wires bridging through, and what that meant was that I could use those PCBs and make them work. It was a way of getting us out of a sticky situation, so that at least while we were waiting for the correct PCBs to arrive, we could use the slightly dodgy PCBs and they would function electrically in the right way. And if we'd gone to the trouble of doing it, what we could have done is actually used all of those existing PCBs and not had to make new ones, but the labor involved in doing that little patch to every one of them was just too much. So much easier to just order new PCBs. But it did allow me to make a few of them. So for example, well, this little stack of dodgily stacked ones here. So these are, so this is a version 1 PCB, and it's got the displays in it, it's got the little patches applied to the thing. So let's see if I power this up. I've got no idea what software is on this, if any. It may have just MicroPython on it, it may have, oh no, it's got ICO stuff installed on it. So I powered it up and you can see the displays are working. And this is with the PCB with the incorrect pin out. So that little patch procedure has worked on both of those displays. And these displays you can use as buttons. Don't know if you can hear that. I'll put it near the microphone. So that was me pressing the displays and basically using them like touch screens, even though they're not touch screens. because the switch that the displays are sitting on is activated when you press them and bend them. So if I press that display, oop, got to get the angle right, there. If I press the display, it bends very slightly and the switch is activated. So we've got two switches that we can activate that way. Yeah, right, okay, so Station 240 said, my one roll of that wire wrap wire has lasted me ages. Yes, I've got wire wrap wire. I've got 4 colors of it on my little dispenser over here. I've got a wire dispenser sort of screwed up underneath the shelf on my bench. And I've got more of it somewhere. So I've just got some common colors on there. And so Dodgy said, how long would that last as a switch? I have no idea. So we are going to see how long these last. And this is not my idea. This idea was stolen from FreeDeck, which is the open source equivalent of an Elgato Stream Deck. And they do that with 6 of these. In fact, let's just have a look over here. Something that I just put together recently. So this is a FreeDeck board. So it's got an 80 mega, what is it, a 16U2 or 32U4? No, I think it was a 32U4 on there. So there's USB host, there's a USB connector on there, SD card, and some multiplexers, I think they are for driving the display. So this is 6 of those little displays, and in this case it's still got the covers on it. I'm going to peel that off. So satisfying. And then each of these has a button behind it, so if you press it, it can send a keyboard event. So this is in fact, I'll plug this in. Hopefully we will see it do something. I think it's just displaying numbers or something, or letters. Yeah, there we go. So you can see that it's displaying letters. I just got a whole lot of stuttering on my video. I don't know what's going on. So you can see letter C, letter B, and this is being defined. There's a config on the SD card, and then when you press one of these, it sends that as a key event. So I've now plugged this into my computer. It's come up as a keyboard, and if I press that, it's like I've pressed the A key on the keyboard, because that's just what I happen to have it bound to, but it could be like a combination of function keys or whatever you need. These are all totally configurable, and they can have different graphics on them, so you can have an icon. The idea is that you use this for controlling things like OBS for live streaming, and then you can press different screens to change between different camera setups and change different things. So as you can see, I'm not using this yet. I've just put it together, but I haven't made a case for it. Now I'm going to find, what will I find? How about Sublime Text? I'll just open a text editor and I'll get rid of that, make a new one, and I've got to change my keyboard layout back to regular Australian QWERTY keyboard, just because of the weird way this mapping happens. Switch myself back to desktop. Okay. Can I zoom in? I don't know if you can zoom in. I can probably change the default font, but is there zoom? No, there's not. There's no zoom in Sublime Text. Anyway, let's see what happens. I'm holding this up, and if I press, which side is it? That one? You can see that the letter C just appeared. I'll keep pressing it. So this is just clicking the screen, the little OLED screen. The letter C is appearing in the editor, and if I click this one, the letter A appears in the editor, because this is appearing to be just a keyboard to the computer. And when I click the screen, it sends the key event that's been configured for that particular screen, and the computer just thinks that you're typing on a keyboard. So you can then use that for sending macros or whatever you want to do. I got as far as testing it by just assigning the letters A, B, C, D, E, F to the 6 screens to see that they worked. But next up I need to configure them with proper images for different camera setups in OBS. I also need to 3D print a case for this. Now, there have been a few open source Stream Deck equivalent projects recently. There have been some really interesting ones. This one is the hardware approach using single color OLEDs. And there's also one I saw recently that uses a large touch. There's one with an ESP32 with a large touch screen and then just displaying icons on the touch screen. But there was another one that I saw which is also interesting, where it's got a large display, but the display is not a touch screen. And then there is a second layer PCB over the top of it with holes in the PCB, and then clear acrylic pieces over the top and buttons around the edge. It's very hard to describe, but when you see it, it's actually an interesting mechanical layout. So you have mechanical buttons that when you press them, they are activating switches that are on the sides of the buttons, but you can see through the middle of the button to see the screen behind it. And that's how they're doing their dynamically updating displays, which is an interesting idea. So yeah, right now there seem to be quite a few different little Stream Deck replacement projects that are being very actively developed, which is really cool to see. Yeah, I have been mostly missing the chat, but I've just seen a couple of things. So Johnny said, I use different colors for my wire wrap wire bodges. Yeah, the reason that I've got a few different colors for wire wrapping is that back when I was doing actual wire wrapping a long time ago, I was trying to be sensible about it. So I would use black for ground connections, red for power, blue for data. You know, there were different colors that I would allocate. So when you look at the actual wire wrap board at the end, it makes it easier to figure out what's going on, instead of just having every single color, every single connection the same color. That can be really hard to follow. Yeah, so free touch deck, yes. So there are a couple of comments I see in there talking about these other Stream Deck equivalent projects. So Dustin Watts did a similar one with a touch TFT. Yes, that's a really cool project. This one was, I'm really sorry, but I've gone blank on the name of the person who designed this. There was one person who did the original project for the free deck, but that was just done as like a bit of a bodge up on some Vero board. And then the PCB, so this PCB that I've had fabricated, that's not my design. I just grabbed the Gerbers for it and sent them off and had them fabricated. And I have totally gone blank on the name of the person who designed that board. I'm really sorry. It's someone I should know too. So, Marcus Lyon said, have you used Enosian buttons? No, I have no idea what an Enosian button is, but that seems like a squirrel that might be worth chasing. Hang on, I can't type on this keyboard if it's in QWERTY. It just comes out as gibberish. So back to Dvorak. All right, Enosian button. I have never heard of that. Oh, okay. Are they like the wireless LED control standard? Alright, that looks like something that might take a little bit more investigation instead of just, no, I don't want to subscribe to your website. Whoever wants to subscribe to a website? Enosian modules for open standards. Okay, I don't quite get what that is all about, but thank you for pointing that out. Adam Welsh. Yes, Johnny Bergdahl just said Adam Welsh. I think it was Adam who designed the PCB, this one I'm holding right now. So yes, Adams is a name that I should have remembered. So Ooh. Okay. S. Leonhardt said, in ocean, meaning energy ocean, meaning no need for battery and switches. Yes. Yes. Cool. So it's like an energy, I don't know if that's energy harvesting or not, technically. If you're, it's really just energy generation. I suppose that's a little bit of a, not generation. You can't actually create energy, but you can convert it. So I suppose everything is energy harvesting. There is this term, energy harvesting, when you do things like have a device that is powered off, say, an RF signal. So it's scavenging tiny amounts of power off some source that is ambient, so it's just around it, and then using that power to do something. And in my mind, it's a very slim difference in definition between energy harvesting and just using an energy source. So if you have, so if you've got a button that doesn't have any battery in it, it's got no other power source, and it's activated when you press it. So you are mechanically activating the button, you're moving it, and that movement is generating enough energy. It is, okay, I'll just use that term. It's generating enough energy that when you press it, the electronics inside the device can power up and they can do something useful, like send a signal or whatever. What it's doing is taking the energy that you have imparted to the system as kinetic energy when you're moving the thing, and it is converting it into electrical energy, and then it is using it for its own purposes. It's kind of energy harvesting, but in many ways it's the same thing as it's like a hydroelectric power generation system. You've got kinetic energy, you've got force that is being converted into electrical energy, just like in a power station. It's just happening at a tiny, tiny, tiny level. So it's sort of energy harvesting, but it's also the same sort of thing that has been done for however long we've had hydroelectric power, which is a long time now. Speaking of which, many, many years ago, I think about 22 years ago, I went to Niagara, which was really cool. Niagara Falls. It was when I was in Montreal working on an industrial project, like it was an IoT project before the term IoT had been invented, and my wife and daughter came over. My daughter was just a baby at the time, and we went to visit Niagara, and just near on the upper side of the falls there is a very, very old hydroelectric power station. I think it was one of the, if not the first, hydroelectric power stations. So, what am I talking about? I have no idea what I'm talking about. I think I need a drink. Okay. Now, yes. All right. So I had some messages from Andy in my little back channel, which I've been ignoring. Well, not ignoring deliberately. I just hadn't noticed it. So this is getting back to the whole thing about failures of devices for the badge project that we're working on. And something that Andy pointed out is that there are other failure modes than just complete failure. And so on that picture that I was just showing you before, this one right here, what you can see are these solder bridges. Now, it is quite possible that on a device with this chip on it, and if we looked up what these pins are, we could find out. But if, for example, you had solder bridges between a couple of GPIOs, it may well be that that board will power up and it will appear to work perfectly, but you will have a short circuit between a couple of the pins. So if you've got inputs or outputs that you're trying to read or write, they may end up being tied together, and then it'll fail in your specific application. So we also need to be able to test cross links between all of those pins to be able to catch situations like this where there is a solder bridge between two pins. The chip itself works fine. When I say works fine, I mean it powers up and you can reflash it, and Wi-Fi might work and all of those sorts of things. You think you're fine, but then what you'll discover is that you press this button on this input and then you get two inputs going, two inputs being asserted instead of just one, because those two pins have been bound together by a solder bridge. We have to be able to catch that situation as well. And so what we need is a test procedure that is going to be able to catch all of those sorts of things. And that sort of situation is actually something that is tested for on Freetronics boards. So one of the test procedures that I have for things like the Ether 10 and the Ether Mega is there is a test jig at the factory, and what it does is bridge every second pin together. So every pin is bridged in pairs, and it's a passive test jig in this particular case. So there is a whole series of tests that those boards go through. There's not just this one test, but this particular test, what it does is you have this passive tester that attaches to the target board, and it bridges together every pair of I/O pins. And then what you do is in the there is a test program that loads up on the target board, the DUT, the device under test, and it does. I'm trying to remember the exact sequence. It's years since I've looked at this. It'll do something like put all of the pins into input mode, and then it'll put one of the pins into output mode, and it will assert it. So it'll drive it high or low, whatever the opposite is of your bias resistors. So if you've got pull-ups on all of your inputs, you drive one of the pins low, and then you read the state of all of the other inputs. And what you expect is that all of the other inputs should be unchanged. They should not be pulled low, except for one, and that is the pin that is tied to it. And what that's testing for is the fact that you are actually driving the output pin because you are measuring it, and it's testing the fact that it's not bridged to any of the others because you're measuring that it's not asserting any other pin when you drive that one low, except for the one that you're using to measure the fact that it's being driven low. And so then you just work around the entire thing and check every one of those pins. And there are a couple of different ways of designing testers like that. I mean, that's not an absolute test, because if, for example, you had your pairs of pins, say you were doubling up pairs of pins, and on a typical board, what will happen is, say you've got 8 I/O pins in a port, and those pins might be like PA0, PA1, PA2, etc. through PA7, will be mapped in a linear way to 8 I/O pins on your headers. Now, if you have a solder bridge between two adjacent pins, as we've seen on this right here, now imagine that you had, on your tester, you were jumping across the first pair of pins, and then you're jumping across the second pair of pins, and then the third pair of pins. This would actually pass the test, because your tester is bridging those pins anyway. So to reduce the probability of that being an issue, what you do is, instead of pairing up adjacent pairs of pins, because that's where the solder bridges are most likely going to occur, you pair up like opposite pairs of pins. So if you've got a couple of rows of headers, say you've got an Arduino board and it's got a row of headers across the top and a row of headers across the bottom, what you do is pair up across the PCB. And if we were looking at a chip like this is an ESP32, but still, just imagine this is a processor on an Arduino board. What you would be doing is pairing up, say, this I/O pin down here with this I/O pin up here, and then this I/O pin here would be paired up with this one down here. So so what that means is that the probability of there being some kind of a solder bridge or a fault on the device under test that causes those to be bridged is incredibly low, and your external bridge on the tester can be used as a valid way of measuring that. But of course the better way to do it is to have an active tester. And with an active tester, what you're doing is not passively bridging pairs of pins together, it is just reading the state of all of those I/O pins. So what you would do is have a tester which has connections to each of the I/O pins on your device under test, and you are just reading their state. So on your device under test, what you do is you tell it, okay, drive the first I/O pin low, and then on your tester, you read every I/O pin independently, and you see that that one pin has gone low and the rest have stayed high, and then move on to the next one. So yeah, with an active sort of test system, that you can remove those potential problems like bridges across the pairs of pins. But for a simple tester, it is probably adequate to make a jig that bridges pairs of pins, and then you can check that way. Okay, what am I talking about? I don't know. All right, so looks like there's some interesting conversation going on about oh yeah, okay, so Esley and Hart said, okay, I need to chase that squirrel a bit. Anyone know where I get the PCB files for this 6-switch OLED thing PCB? Yeah, if you search for FreeDeck, you will find it. And like result number 1, I believe. So FreeDeck, I'm just going to do a search for it. And here we go. So the first result is Korowi. So the Korowi account is the the original developer of the FreeDeck, and what you can see here is the version that was done on a bit of proto board. It's got a Arduino, what is it? Pro Micro, excuse me, hanging off the side, and it's got the OLEDs just mounted on the Vero board. Hang on, I've got to do this properly. That's better. Okay, so who was this? So Korowi, I don't know. Oh, Killian Gossowicz is the original developer of the FreeDeck, and then Adam Welsh designed the PCB for it. So to search for FreeDeck, you'll find this. Go into 3x2, and the 3x2 has a couple of different versions of it. There is a surface mount version and a through-hole version. All I did was come in here to the surface mount version, grab the Gerber zip and send that off and have it produced exactly as is. I didn't change anything. I didn't even generate the Gerbers. I just used the ones that are right here and sent them off. Now, one thing that I personally don't like about this is it uses the QFN version of the 32U4, and as I've said many times, I hate QFNs. If I was doing this, I would have laid this out with the TQFP version, which has a bigger footprint, but I mean, it's not like this PCB is tight or anything. There's plenty of room there. Just makes it easier for hand assembly. And yeah, it was okay. Apart from that, I was doing an order with, on one of my regular DigiKey orders for some other thing. I just included a couple of the other parts. So I didn't have the multiplexers, and there was something else on here that I didn't have. So I just ordered like a small number of each of the extra parts on here. But it's basically a processor, a couple of passives, an SD card, and these ICs, which are only, $1 or $2 each, so not too much of a problem. So if you want to build yourself a FreeDeck, go and check that project out. All right, so looks like there is some interesting conversation going on there, which I have been missing. So Magic Blue Smoke said, so that when the sensors refuse to ping, I can send an automation to send a shutdown message to my router and home server. Okay, so is this detecting a power out situation? Yes, looks like it might be. Yes, so detecting power failure and then doing a clean shutdown on various things using what little remaining power you have on your UPS. All right, now mental pause. What the hell am I going to talk about now? I don't know. So, sensing for USB. Okay. All right. Where to from here? Okay, so let's see what I can find in Discord. So what I'm going to have to do, I think, in Discord, because I am so far behind, is declare Discord bankruptcy. I'm going to jump back into Discord, but I know that there is a month worth of conversation that I have totally missed, and I'm sorry. I will jump in and see what I can find. Let's see. I'm curious. System log, 42 new people have joined. Cool. So, yes, I have not been paying enough attention. It's red everywhere because it's got these little notification things, you know, the little circle with the number in it that says how many notifications there are for you in that particular channel, and just about every channel has. Look at this. Hang on, where are we? Desktop, go. So I'll just click on that because I don't want to clear the notifications on the other. So I've got all these little notifications on different channels in Discord. Lots of things for me to follow up. What is that one? Board design, 13 notifications. Okay. I am going to get into Discord and try to catch up, if I can. All right. I get the feeling that there is some interesting conversation going on here. Voice activation. All right. I've been working on a thing just recently that I am so tempted to show you, but I don't want to. When I show it, I want it to be ready, and it's not quite ready yet. But I have this thing that I've shown to a couple of people as a little secret thing. It's related to voice activation. And no, I won't talk about it. I won't show you. I could, but I won't. It's going to come. Yeah, that's a video that's coming. Speaking of which, let me switch back to front view here. Now, if you look behind me over, which side? That side? There. Look, you can see the water cannon. I've moved to the back of the bench, and that is because I cleared some space. My laptop is sitting there because yesterday I was sitting there doing some filming for the next Superhouse episode. And if I get right onto it today, continuing, now that, when was my last Superhouse video? I think it might have been about March, which is just ridiculous. Colamids, drone delivery, no. Oh, you see that, you can't quite see it, but just up there, there is a drone with a package release system on it. And so that was a package release system that I made with my friend Nick. He did the design. So this was before I really knew how to drive Fusion 360. I sketched out an idea and he drew the design in Fusion 360 and we cut it on his laser cutter. And there is a little servo-powered package release mechanism under that drone so that we can fly it somewhere and then drop a package, or you know, bring it down, leave a package on the ground, and then fly away. And that is fun. You can drop things from the sky. And and talking to my friend that owns the local post office, I won't name him because I don't want to get him in trouble. I was telling him about this. This was a couple of years ago now, actually. We were working on that. I was working on that with Nick. And yeah, so I said to him, I was talking to him about this project, and he said, you should send your orders down to me that way. So I've been so tempted to set up that drone, and then when I have Freetronics orders or Superhouse orders that I need to ship, attach it to the drone, fly it down there, drop it into the back of the post office, and then bring the drone back home again. But the problem is, that's illegal. I really can't do it because it means flying over other people's properties and things. No, not a good thing to do. But yeah, playing around with that package delivery system was a fun thing to do in a controlled environment. Anyway, back to this. So this area where I've been filming, yeah, the next video for Superhouse, if I get straight onto it, so after this live stream I will have lunch, but then this afternoon I could do a bit more filming. It is conceivable I will have the next Superhouse video ready to upload this evening. I really package to the node, PTTN. Yes, that's right, Michael. Yes. Drones. Okay, I'm trying to avoid chasing that squirrel because it's such a fun topic. So yesterday I did some more recording for the setup video on Grafana and MQTT and Node-RED and all that sort of stuff, InfluxDB. And I've been editing, so I've got a fair bit of it laid out in Final Cut Pro now. I've got to record the last little bit, which is showing the setup within InfluxDB and using Node-RED to take the data from being published in MQTT and stick it into the database. And then doing charts and things in Grafana. And so when I describe it like that, it sounds like, yeah, 90% of the video is still to go. But those particular parts of it aren't all that complicated, really, when you lay out the system and you look at the little building blocks. So I don't think it'll take me all that long to finish. You know, recently I've been, because my computer is very old, I've recently become obsessed with looking at all of the new Apple M1 chip reviews and things online. So I've been watching lots of YouTube videos. In fact, I've watched so many YouTube videos about the M1 chip, like the new MacBook Air and the MacBook Pro and the new Mac Mini, that if I had just spent that time doing billable work, I could have just bought one by now. Oh, anyway. So I, well, dodgy. This particular fix coming up is not going to be a very interesting one. The video, it really feels like this video that I'm working on right now, and I think this is partly why it has dragged, and why my work on it has dragged, is it feels like a video that just has to be done to get the tutorial out there. It's not that I actually care about it. It's not even, I don't think it's even all that interesting. It's just, this is a useful building block. This is something that you can do when you're putting together a home automation system or some kind of an IoT project and you want to do data logging and reporting. You need these tools. So this is how you install them. And the end result is, you know, it's fine. It's data logging and reporting. Everybody needs it. It's useful. But it's not the sort of thing that is fun to make a video about, or it's hard to make it interesting. So yeah, so S. Leonhardt said, look at Telegraph for Influx. Yes, I know. And I'm actually talking about that in the in the video. So, well, I'll give you the reason now. So yes, with Telegraph, what you can do is use that as a front end to InfluxDB, and you can acquire data from different sources and then stick it into the database. So what I'm doing in my system is using MQTT as the message broker, and then subscribing to that using Node-RED. When it sees data coming in, it does whatever it needs to for formatting purposes, and then sticks it into InfluxDB. Now, as S. Leonhardt said, I could get rid of Node-RED in that situation and use Telegraph instead, but the reason that I do it this way is that I already have Node-RED for other purposes. What I'm trying to do is use software that is not necessarily only used for that one purpose, but which is used for multiple purposes. And in an automation system, Node-RED is useful, and many people already have it installed. And it also gives you a lot of flexibility for doing things like data manipulation and adding other logic as well, because you might want to not just stuff it into an InfluxDB database. You might want to have other automations that take place based on data that comes in. So if you are logging data from, say, like just up in there's an air quality sensor mounted inside the case of that 3D printer. You might have a situation where you have an automation that says when the particles per deciliter in the 2.5 micron range exceeds a value of 200, then turn on this air purifier, or whatever automation you want to do. So Node-RED is really useful for that sort of thing as well. So Telegraph is useful as a way of getting data into InfluxDB. It's really cool for that. But yeah, I've just gone, and it's certainly a valid choice. You can do that. That's great. And also, you don't even need to use InfluxDB. You could use any one of many other databases and other charting systems and other message brokers. There are different ways of approaching all of these problems. It's just this particular set of 4 pieces of software are the ones that I chose as a good general purpose way of acquiring data, storing it, charting it, and potentially doing automations based on that data as well. So yeah, Telegraph is something that I should probably spend a bit more time playing around with. I don't really know anything much about it other than at a very general level. So, but yeah, I've certainly had many people say, use Telegraph, and enough people have said that it makes me think, yeah, I really need to put the time into figuring out exactly the benefits of it and how it works. Yep, cool. Yeah. Yes, dodgy. 92.376% of statistics are made up. Yep. Yeah, so as Peter said, I think that video will be really good, as you'll be able to basically presume into the future that your viewers have watched it, or you can say for a live stream, this will build on the setup video. Yeah, exactly. That is really why I'm doing this video. It's like the Tasmatizer video for installing Tasmota onto target devices. It means I can do it once, and then later if I do any project which is related to data logging, I don't have to show all of those steps again. I can just say, install these, go and watch this episode, install that stuff, and then come back and get on with doing the interesting thing. Alrighty. Now, as Leonhardt said, I have a bit over 6,000 data points in the house that I pushed to Influx. Like, what? Please explain. Or, yeah, no one outside of Australia will get this, but please explain. Now, I would like to know what those 6,000 data points are. Is that 6,000 individual parameters, or is it 6,000 data points over a period of time? And to most of these points, I react via deep learning. Interesting. That sounds like I need to know more about what you are doing. Yeah, as Michael said, big house or too much data. Okay, so this is touching onto a squirrel that is multicolored and multidimensional and runs in every direction simultaneously, which is machine learning. And that's a squirrel that you can chase for the rest of your life. Jack's text said 6,000 data points. I don't like it. Yeah. I would really like to talk a bit more about machine learning in the future on Superhouse. I think that's a subject that it definitely needs a... there is so much scope for that with home automation and IoT in general. And I certainly am not an expert on it. I've played around with it a little bit, basically following the bouncing ball, following other people's instructions, like my good friend Andy, who knows about this stuff. He's the one that I that I pay attention to. I know enough about it that it's interesting and can do cool stuff, but I rely on other people who actually know what they're talking about. So Peter Lawler said, any comments on the ESP with RISC-V? Not yet. All right, so RISC-V is one of these subjects where once again, I know it's interesting and I don't know enough about it. I actually have a couple of RISC-V dev boards here. I've backed them on Kickstarter over recent times, and not so recent times, because RISC-V has been around for a little while. It's not a brand new thing this week. There have been RISC-V boards around for years. And I think it has the potential to be incredibly interesting, but I don't know what I would use it for, I suppose, is my initial take on it. What I would really love to do is get my old friend Angus here on the live stream and talk to him. Maybe see if we can get some secret inside information out of Espressif. So, yeah, I should twist his arm behind his back and say, you're coming on the live stream and we're going to talk about ESP stuff. That would be really, really cool. Yeah. So, I'm mentally stalling because of stuff that I'm seeing go through on the chat. Sorry about that. Okay. I can't say anything sensible about RISC-V. So it's a very good question, Peter. And so there are a couple of announcements. All right. I should give the very, very quick backstory as to why Peter asked that question, for those that don't know. There has been an announcement from Espressif that they are releasing a couple of new devices. So far we know of... So, over the last few years, Espressif came out with the ESP8266, which was the thing that really just booted them into the stratosphere, and the ESP8285, which is the same core, but it's got some flash memory built in. So you can build a single chip device instead of having to have a separate memory chip. Then there was the ESP32, which has been through several different hardware revisions. Fairly recently, the ESP32S2, which came out very recently, which is a single core version. So the existing ESP series chips have been based on, I believe, the 10 silica core, and there's been the multi-core versions like the ESP32. The classic ESP32 has 3 cores actually. It's got the 2 regular cores that we're used to using, and there is a low power core as well. And then the ESP32S2 has a single normal core, and I think it also has the low power core, plus other things like built-in USB host. which makes it a very, very interesting chip. Having a single core ESP32 with built-in USB is basically like, and Wi-Fi and Bluetooth is basically the dream for a lot of projects. Many projects you don't need USB, but for many projects you do. I would love to have, well, something like this, for example. If this could have an ESP32S2 on it, which means that you could do USB connection, and then you could have it emulate a keyboard via USB. You could also emulate a keyboard via Bluetooth, so you could make it work either Bluetooth or plugged in if it was using an ESP32S2 chip on it. So there are really cool things you can do with the S2. But bringing us up to today, or the last week or so, there has been an announcement from Espressif that they are releasing a couple of new chips, and one of them has the RISC-V core in it instead of a Tensilica core. And so RISC-V has had a lot of attention over the last couple of years. A lot of development has gone on with it, and being able to buy a little module off the shelf with a RISC-V core in it, and coming from Espressif in a package that we can all deal with, could end up finding its way into lots of projects. That could be interesting. Yeah, so as John Spencer just pointed out, we discussed using the ESP32S2 for the swag badge simply because we could do keyboard emulation with a single chip. Yeah, so on the swag badge at the moment, what we ended up doing was going for the Lowland 32 as a module rather than putting discrete parts on the PCB, and that was because we didn't want to have to do several hundred of these with reflow and putting all the parts on. Given the time that we had available, the decision was we wanted to make it very module based. So just use existing modules and use this really just as a carrier PCB. It's just binding things together. The only parts that are actually soldered to this PCB, other than the displays and the Lowland, are the two buttons that are underneath it. And I just hand soldered all of those. So I soldered 600 and something buttons on, and it didn't even really take that long. I just sat there and like, next, next, and just did it under the microscope with a hand soldering iron. I didn't even reflow them because it was faster to hand solder them than to put on paste, put the parts on and run them through the oven. But what would be really nice is if this could also be a USB device, like a HID, a human interface device, and you could plug this in and use this like a keyboard on your computer. So when you use the touch sliders, where are we? These touch sliders on here, we could make it so that that could be input to the computer as if it was keyboard events, and when you click the screens, they could be keyboard events. So this could be a keyboard as far as the computer is concerned. If we had a device on here that could do USB HID, and at the moment these Lowland 32s, they've got, what is it, no, it's not a CP series. They use some horrible USB to serial converter chip on it. I can't even remember which one it is. Probably it might be a CH340G or something. You know, one of those ones that's so bad that I need to have therapy after I've mentioned them. And so we can't do HID. We could do it on Bluetooth. So we could make this a Bluetooth keyboard device. And it would be nice if it had been done with an ESP32S2, but we didn't. Plant monitoring. Ooh. So Dodgy Brothers Engineering said plant monitoring, and right above that was John's comment. In fact, I think I can find this. Hang on, I'm going to take a swig of this and go and look for a box. You won't be able to see me, but you'll be able to hear me because I'm still on the radio mic. And somewhere out here, I have a box of stuff, including some boards of John Spencer's. Yeah, so I'm now wandering around out in my garage while you are just looking at an empty chair. Where is it? Oh, that's right. I reorganized things recently, so it should be over this side. Soil moisture sensors. I'm sure I had a box specifically for John's project. What do I have here? Yes, plant. Yes, this is it. All right, I have the box. Bringing it back in. This is a project that John Spencer designed a few years ago, which was a very cool project. I've got all sorts of stuff in here that I haven't seen for years. I really should have taken this battery out. It's probably not very healthy right now. Well, and there's so much in here. Sensors and cables, and oh, there's the... Ah! All right, I'm going to put this away. There's a solar panel. It's still got a bit of its plastic protective film over the top because it's never been deployed. This is a board. I'll just show you the back of it first. Geelong Linux Conf AU 2016. This is a board that John designed for LCA 2016, and this is the ES plant. It's a garden monitoring system based on the ESP8266. Hang on, I've got to make some room for myself here, and I've dropped some things. So soil moisture probes, which plug into it, and RGB LEDs, just because you can never have too many of those. In fact, this is probably easier to show if I switch over to my overhead camera. Overhead. The wrong thing. No. I've just been talking to you expecting that you could see what was going on, and you were sitting there looking at the end graphics. Oh, I'm sorry. I wonder if a whole lot of people just logged off. All right, so we're back. We're back. Yeah, so LCA 2016 was, I think that was Geelong. Yes. I think it might even say it on the PCB. And that was, as I was just saying when I thought you were still here, that was a year that some really bad stuff was happening for me at the time of LCA. And I barely saw the conference. In fact, I don't think I went to any of the main conference sessions that year. There was the Open Hardware MiniConf, of course. I was there for all of that. Oh no, I wonder if there's any power in that battery. Doesn't look like it, unless there are no LEDs, which is quite possible. So, this is John's ES plant project, and the idea is that this is a garden-based monitoring system, and it's got the ESP8266 on here. Now, one of the limitations of this, so this was in January 2016, which meant that it was designed in, when would it have been designed? Maybe October, November 2015, around that time. And that was very early days for the ESP8266. So there was the ESP8266 on this module, which is the ESP12 module, and it's got very limited I/O. So one of the interesting things that John had to do on this board was have a secondary processor just for managing I/O. And if I bring this in, maybe not quite that much because we still need the camera to focus. Come on, focus, focus. I think that's focused enough. It's about as good as we're going to get it. So there just wasn't enough I/O on this module to deal with all of the stuff that he wanted to talk to. So there is there's an STM something processor somewhere. Is that it? Might be. Which he's using as a secondary I/O processor. So so there's some firmware in the STM32 which is communicating with different sensors and then communicating with the ESP8266, which is doing Wi-Fi and all of those things. Now the thing is that I am probably totally misrepresenting this. Oh, look, it's designed by John Spencer and Angus Grattan. So yeah, Angus is our mutual friend who works at Espressif now. After he left me, it broke my heart. This, I am probably misrepresenting this and telling you things that are wrong. And John is probably sitting in here in the chat screaming, saying, no, 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 you're making stuff up when you don't know what you're talking about, which is my usual state. So, okay, the general idea is that this device goes out in your garden somewhere. It has this battery on it so that it can run 24 hours a day. It would go into like a sleep mode so that it would save power. And there was that solar panel that I was waving around at the camera earlier. So this would be mounted in an enclosure with the solar panel nearby, and then it would talk to a bunch of sensors and then do reporting. So we can see here it's got nice labels on here. So temp sensor, and I've got one, where is it? Over here. There's one of these ruggedized temperature sensors that I will drag out of the box. So I think this one is just like a DS18B20, you know, the very standard Dallas one wire bus temperature sensors, but it's inside this enclosure so that it's ruggedized. You could stick this in the ground or just leave it out in the rain or whatever you want to do. And that plugs in here, other way around though. And so we can read the environmental temperature. We've got a PIR sensor, so infrared motion detector, and WS2812B. So this is going out to this little RGB LED ring, so we can do things like display status on it, because LEDs are cool. And what else can we see here? UV sensor. You can just see there's a UV sensor thing there, and the connections for that. I don't know if I've got one. I might have a UV sensor. Oh yes, I do. Looks like it. This is a little DF robot module UV sensor. And that just plugs into it here. Once again, am I doing that backwards? Probably. Anyway. Oh no, that's the way it goes in. So UV sensor goes in there, so we can measure our local UV levels. There's a soil moisture sensor that comes in here, and that is what this is connected to. Now I just saw some questions in the chat about these sensors. Now there is an issue here with soil moisture sensors are harder than you would expect. You think it's easy, they're not. Okay, correction. You can make a soil moisture sensor that works easily, but you can't make a soil moisture sensor that works for a long time easily. Making these things last is really, really tricky. The obvious solution, which is what this does, this is just PCB. Like you can see, this is simply a piece of PCB. It's got a slot in it, and it's got these two connections. And all you do is you stick this into the ground. So, you know, your ground level is here, and you stick this in so that this is embedded in the ground. And then you measure the resistance between them. And in theory, decreased resistance means increased moisture. So you can measure how much moisture is in the water using these sensors. But there is a problem. The problem is that when you run power between a couple of metal surfaces like this, you get a chemical reaction occurring, and the metal here doesn't last very long. I can't remember the details of the reaction, and if I try to say anything, I will just be telling you the wrong thing, so I'm not going to. But basically, over time, these contacts end up being eaten away, and it can happen really remarkably quickly. So there are a couple of ways of things that you can do to avoid that if you want your sensors to last more than a couple of weeks. One is that for some sensors they reverse the polarity on them, and instead of just constantly running, so when you typically have if you're trying to measure the resistance between two objects, normally what you would do is have a voltage divider. So you've got, say, a resistor going from 3.3 volts to a sense point, to your analog input, and then from that same analog input you have another resistor to ground. And that bottom resistor, or it could be the top one, let's just say the bottom resistor is actually just a connection across these. And then the amount of moisture between these points makes this resistor vary, and therefore the voltage divider varies, and therefore your analog input reads a different value. So your analog input then just becomes the representation of the resistance on the sensor. And when you think about that, what that means is that one side of this, if you think of this as a resistor, it's not, but imagine it's a resistor. One side of it is tied to ground, the other side is tied to a higher voltage because it's connected to your analog input, and you've got the pull-up resistor on the other side. What you end up with is current flow from one contact to the other, always in the same direction. And so you've got a positive and a negative relative to each other. And over time, that current flow causes a chemical reaction which makes metal migrate off one of these contacts, and you'll find that one of the contacts in particular will disappear quite rapidly. So one thing that is done sometimes to extend the life of these moisture sensors is to reverse the connections on them. So take a reading or take a few readings and then reverse the connections, take a few readings so that you have current flowing in both directions, and it eats the two contacts at a more even rate and makes them last longer. There are other ways it's done as well. This is a really simple way of doing it. I've got some other soil moisture sensors around somewhere. What have I got in here? I don't know. Oh, here's another one. This is a better way of doing it. So this is what I was getting to. This is a capacitive soil moisture sensor. So these ones that we're looking at here are resistive. It is two exposed contacts with material all around them, like your dirt all around it, in direct contact with those contacts. Funny about that. And that is how the electricity flows between the contacts through the dirt. So there is actually electricity flowing between them, and that's what causes the problem. This type of sensor, and I'll get it out of this case, this is in a little 3D printed case for another project. This one is a capacitive system, and it doesn't have that same problem. Now we've got some exposed electronics up here, which is no good being out in the weather, but you can see that there is no exposed contact on this part of the probe. So if you insert this into the soil, so you've got your soil level here and your probe, you stick this into the ground down to that line, jam it in, and you've now got a probe that is inserted in the ground to measure the soil moisture. It's not using two exposed contacts and passing electricity between them. What it's doing is measuring the change in capacitance of this part of the sensor. And if I get the, I'm trying to get the light at just the right angle so you can see it. I had it there for a moment. Oh, here we go. Okay, so if I get that light just right, you can see that there is a contact that runs down here. It's like a loop. Comes down here and comes back up here. And then there is a bit of the PCB in the middle that is, there we go, that's another contact sort of in the middle. And so there will be capacitance between these contacts. And the amount of capacitance is going to depend on the dielectric. And the dielectric in this case is the dirt that is all around it. Well, it's a combination of the PCB, of course, because that's there as well. But that's constant. What is going to vary is the moisture of the dirt that surrounds these, and that is then going to affect the capacitance. So what this circuit does up here is measure the capacitance across these contacts. Now, because these contacts are covered in silkscreen, no, not silkscreen, they're covered in solder mask. It's not directly exposed metal. It means that and also you're not passing current between them, like from one exposed contact to another like you are with this. It means that these don't degrade over time. Well, certainly not like the exposed contact type. These ones will last much, much longer. It's a much nicer way of doing it, particularly if all of the electronics up here are weatherproofed. Now on this particular one, you can see the edge of the PCB is exposed. So if you just shoved this into the ground, you would probably get some moisture ingress over time. You might get some degradation of the PCB. So I think if I was going to stick this into the ground, I would probably paint it. Maybe even just spraying this with some spray paint or something would help to make this totally sealed, prevent any moisture getting onto any of these contacts. Ideally, it should have a conformal coating, which is a type of coating that goes onto devices that need to be exposed to moisture and other nasty adverse conditions. So if you had some conformal coating spray or whatever goop, you could cover this with the conformal coating, but even just some spray paint would be a step up. And what you can end up with is a sensor that you put in the ground and it could actually last reasonably well. So anyway, that was a little bit of a sideline. So this system here, so this ES plant project that John designed, is designed to use these probes, which are the resistive type of soil moisture probe. Now these are incredibly cheap. As you can imagine, in fact there's nothing on it apart from this little socket. So that's a two-way pin header. All this is a piece of PCB. That's it. It's just blank board. There's no active electronics in this at all. So these can be produced for a very low cost. Like we're talking about cents. It all comes down to just the area of the PCB. So if you're producing this, it's probably like a 20 cent or a 30 cent PCB. Easy to make. So I've seen other people making other variations of this. So one of the DIY ways to do this is to get a nail, and you need to get a specific type of nail. I can't remember which. It's years since I've looked at this. I think you use an iron nail. I don't know. There's either iron or steel or something. There's a particular type that you get. So you get a nail, which is your central contact, and then you wrap it in plaster, and then the whole thing gets buried in the ground. So you end up with two of those contacts. You have nail wrapped in plaster, and then another one nearby, and you can measure the soil moisture that way. But yeah, doing it like this with PCB material is a very cheap way of doing it, but you have to replace it because these contacts disappear over time. All right, so what else do we have here? Power. Oh, that's the solar panel connection. So this battery is probably cactus by now, is my guess, because it's been sitting in this thing for a few years. Well, since 2016, I assume. Let's see if we've got any voltage on this at all. And yes, I know that this polarity is backwards. Oh look, it's reading 0.016 volts. That battery is cactus. But if I trust fire, yes, you can trust them to catch fire. That has got to be the funniest battery brand name that I've ever seen. Trust Fire. Trust Fire LiPo batteries. So if I got myself an actual functional battery and stuck it in there, oh, look at that, there's a temperature sensor. That is a really cool little part of this design. So you see, when I pull the battery out, there is a little surface mount part that is on the PCB directly under the battery. And I believe that is part of the battery charge management system, because LiPos do not like to get hot. And this thing can sit out in the sun. So with So that's a temperature sensor, and then the battery comes in here. If I clip it in, because there's a protection circuit on the end of this battery, which makes it slightly longer than the standard, and that means that you've really got to jam it into the socket. And in fact, I probably put it in backwards, but did I put it in backwards? I don't know. No, that's positive. Good, I didn't put it in backwards, even though it's dead, so it doesn't really matter that much. So once the battery is in, it's sitting directly over the top of that temperature sensor, and that means that we can do things like detect when the battery is overheating and take preventative measures. So, yes, Michael said backwards equals confirmed fire. What else do I have in here? Oh, yeah, this is I got a whole bag of these sensors. I ordered them ages ago because I was going to do a soil moisture. I was actually going to do a video about garden automation, and so I got all those capacitive soil moisture sensors and never did anything else with it. They're still sitting there in the bag. Plus this one here, which I pulled out for testing, and this enclosure. So this 3D printed enclosure, which way around does it go? That way. The idea with this is that you put the sensor in there, and there is a space. That space there is big enough for a Wemos D1 Mini, and then this space here is for a battery. I think that's an 18650 LiPo cell goes in there, and you know, you wrap all this around, and that connects up to the Wemos D1 Mini, and then when there is another part that goes on top of this, you can close it up. Basically, another 3D printed part is the cover that goes over this, and what you end up with is a little Wi-Fi enabled battery powered soil moisture sensor. So you can, you know, just take this and, which way do you see it? That way, and just stick it in the ground, and then it'll start reporting soil moisture back to your home automation system. So that's an incomplete project, just sitting in the box. I have so many of those. It's a sad state of affairs. I'm going to get that battery out, and I'm not going to put it back in the box because that needs to be disposed of carefully. What does it say? Rechargeable battery, 880 milliamp hours. Yeah, I thought it was going to be a little slogan or something because it's in that italic font, like trust us to catch fire. What other bits did I have for that? I should put all of this back. Oh, that's right, there's this temperature sensor as well. So I'll put that back in the box. And the soil moisture sensors project box can go back on the shelf for a little while longer until I get time to get back to that project. Yes, Peter said, must be about lunchtime. I agree. Michael said, I love that when Samsung recalled all the dodgy catch fire devices and tossed the batteries in a skip, they still caught fire, not connected to anything. Yes. One final little thing was sorry, I was thinking about batteries. There is a particular product that I have been selling for many years, which is the RTC, or real-time clock module. And I had a batch of, how many? I think it was 200, or it might have been 100 of them manufactured. It would have been about a year and a half ago or 2 years ago. They've been out of stock on my site all that time because what we were doing originally was the modules have got a coin cell in them, and the coin cell is used for keeping the time of the clock when power is disconnected. So when you power your project up again, it still knows what the time is. You don't have to reset it. And the modules were packaged with the battery, so the coin cell inserted into it, and a little plastic slip in it so that it wouldn't be using any power. It was electrically isolated. And then when the customer bought the module, they would just grab the tab, pull it out, the battery would be connected, and then you could set the time and do whatever you need to do. And so I had these manufactured, and the modules were sitting at the assembler, and they couldn't ship them to me because you can no longer ship anything with batteries in it by air as air freight, unless, you know, without very specific safety measures being in place. And in the end, we couldn't figure out a way to get them to me in any sort of vaguely viable way. So what I did was get the assembler to take out all the batteries and then ship me just the modules as they are. So for those that care, all 2 people, I now have real-time clock modules available on the Freetronic site again, but I am now selling them without the batteries, which means you have to get a CR1632 battery. I think that's the size. So you've got to go out and get a coin cell and put it in yourself, because I can't include it in the package anymore. Shipping stuff, how is it that moving stuff around the world is harder in 2020 than it was in 2016 or 2015? We could ship things wherever we wanted to then. Well, now we can't get anything anywhere. Logistics is the big bottleneck of the world right now. Okay. Alrighty. Yes, I think it is about lunchtime. I am going to go and get some lunch. And if you're in my time zone, you should too. Or maybe you need to get a midnight snack, or a 2 a.m. snack for some people. So thanks for hanging around, and I'm going to end this live stream, which means that this time it is really going to be the end. It is not me mistakenly hitting that end button, and yeah. It's a good thing that the little scene switching thing didn't also send a stop streaming command, because then it would have just been a premature end. Anyway, thank you for hanging out with me on a Sunday, and I hope you're all having a great weekend. I'm going to do my best this afternoon to spend this afternoon working on that video, getting it finally finished, because I've got a couple of other videos that I am really excited about, including the secret one I mentioned earlier, the voice assistant related one. That is so cool. I want to talk about it, but I can't. I want to get onto those videos, so I've got to get this one out of the way. Just got to get it done, rendered, uploaded, and then I can work on fun things again. So, have a great weekend. Thank you all very much, and I will talk to you later. See ya.